So
Yeah,
they already pushed through one of the exams for me so I can finish. One of my biology teachers had compassion and pushed through that one of the exam instead of having to do it on Thursday. They just pushed it through Saturday because I was not going to be able to have either a good connection internet or either there are the proctorian exams, those ones that they will
right.
pull you through.
Mm-hmm. Oh,
So
good. That's nice.
okay, do you want I open up the 16. Is that the 16, right?
Yeah. Yeah. This week it's interesting because we've got the two quizzes. We also have a project we need to start working on.
Yeah, I was looking on the project and then there are the project has to be only for students, right? Or we can do it for with coworkers.
No, it can be done with anybody. So I already started on working on the design.
Oh, did you? Good.
Oh, okay.
Yeah. So I mean, I told you guys I already took this course, so we have already done a project, and so I just worked on some of the things that I wanted to do something different with you guys. Just what a lot of people were doing in the school here at BYU Idaho is they were trying to have surveys and talk to people, and it's a mess if you want to like talk to people. So because you have to get consent and you have to get approved by the
Okay.
school to
Mm.
do a school type survey. So what we did was we um, we went to parking lots around town in Rexburg and in Idaho Falls, and we saw the car sizes. We did a systematic random sample, and we kind of like looked at different car sizes and we compared it to the national car size preference to our local car size preference and see if there was a similarity or not. Now, we don't have to do something like that, but I just thought it'd be easy since we wouldn't have to fill out any more extra forms for the school or anything. And we all go to the grocery store every now and then, right?
Yeah.
Um, and it's just something you can do as you're walking to your car. You just count every third car and see. But I'm not sure what to do with it this time, and I needed your guys' help. So I'll show you guys what I did, and maybe you can tell me if you guys want to go ahead and do something that I was thinking, or we can all together come up with something new.
Oh, okay. Oh, I was just going to say I also did kind of like a survey before for my work for psychology for the psychology class, and then I got people that got pain, uh, back pain, and they were doing exercise, and people who don't do any exercise at all, and then I have to compare which one have a pain, and then so I did that, and then the people, obviously the people that exercise more, they didn't have that many back pain, but I already have the results and everything. So at work I asked everybody, and then they were all
Well, since we
so
have to
the
conduct an experiment again, like
mhm.
I want to. I mean, if it was up to me, and I'll do whatever you guys want to. But if it's up to me, I would much not. I would prefer not to do survey type experiments because it's just
No, that's okay. That's great. And then actually I am totally agree with you. And it took me a lot of time doing that, and then I have to do a lot of work because I have to compare the Excel and then a spreadsheet and then compare the results and everything. And so it was very, very hard work. So yeah, I understand and I'm totally agree with you, Juan.
so. I
Yeah.
mean, if you guys want to, really quick, could you guys open up the design the study Word document?
Yeah, I already have it open.
And do you have it open, Christina?
I had it open last night. Yes.
Okay, so under the name of the participants, I haven't heard from Megan. Have you
No,
heard?
I was going to ask you one if you had heard anything from her. I
So
haven't.
I'm gonna email the teacher. But the way that I kind of had the work set up was that I was going to design the study. All
Mhm.
members. So step one, I design it. Step two, all members collect data.
Yeah.
Step three, Christina makes inferences / takes action. And then step four, Evelyn makes a PowerPoint. and
Oh,
then
okay.
step 5 we all fill out the group evaluation.
Okay. Yeah, that sounds okay for me.
That sounds good. Evelyn, are you okay making the PowerPoint?
Yeah, yeah, totally fine.
Okay.
The PowerPoint is something that is easy for me. I done it like so many times.
Right, right.
Different
Good.
things.
Okay,
Okay.
that was great one.
You guys wanted to have a special title for these?
Well, let's decide exactly what we're going to do. And then I love the idea of not having to talk to people.
Yeah, that me too.
I think that's great. Well,
I already
and
done
also
it talking to people and
it
was
makes,
the pain.
it makes the sampling hard too. Because, we either need to do a simple random sample or the systematic, like Juan was saying. I mean, just with people, that's a challenge. It's with people, it's a lot easier to do a convenience sample, and we shouldn't do that. So,
Yeah, and typically the type of people who do take the time to answer surveys are tend to be more biased or tend to be skewed in one direction or another.
That's
So,
exactly the other thing that was they were talking in the psychology class. When you are interviewed face by face, you won't get an accurate data. That's exactly what we were studying about. Then they won't tell you exactly the real. I mean, they will modify some of the data.
okay. Um, this is where I need both your guys' input.
mhm.
This is my idea, okay? What
Mhm.
if we did an ANOVA test
Mhm.
for the 3 locations, Salt Lake City, Idaho Falls, and then where's your nearest one?
Christina is.
Wherever, Christina. I don't know, because you'd have to travel, right? Or you could even.
I mean, I have a grocery store here in town. So
Okay.
it's a small town. That's all. Well,
Well,
I mean, it's 8,000 people. So it's not tiny.
whoa, they're moving up in life, 8,000. So what I was thinking, if we did an ANOVA test, we could compare maybe car color preference. We just did like every third. We would start at a random place and then we'd do systematic every third car and we'd record if it's white, black, orange, yellow, And I don't know the specifics. I mean, we'd have to think about it. But there's an idea. We could also do an ANOVA. I don't know. I just like the ANOVA test idea because then we just compare to see if Idaho Falls's sample mean average is the same as, or if one
I'll
of
tell you already. It's white and gray. That's
yeah.
it.
I think white is probably the most common car color.
Really? That'd be funny if, like, here in Idaho Falls, it's black or something weird.
Yeah.
Or
So
my wife is saying it's silver.
yeah,
Mhm.
I know. Well, I have 2 silver cars in my driveway, so.
You have two silver.
But
Okay, so maybe that's not. I don't know. Maybe that's not like the best one. But what are some ideas you guys have?
I
Yeah.
will I will do it while I'm going to work. I take the bus, and
Okay.
so I will just pick the ones that are on the road. They were passing through me. The third car. That's what would be for easier for me because I will have more sampling. And then if I do it in a parking lot, and it just will take me a little while, and then I have a very limited time to go in back and forth. Oh, I can just go outside in my parking lot and check that.
Yeah, there we go. So the only reason why we want to stick to
To
a
one.
controlled experiment, right?
Yeah.
So question number, I guess number 2, we have to pick a population.
right. So I guess for number 1, what exactly are we trying to determine? Are we trying to determine the most common car color comparing what exactly is our question? And do we need to have a type of study where we need some sort of baseline that we can compare to a national average or something? I mean, I don't know.
Okay, so if we're gonna do a quantitative experiment,
Mm-hmm.
then yeah, I mean, sorry, categorical, then like a chi-squares test or things like that, we would need to compare to the national to see how we did to them, because those categorical tests, like we're gonna study in lesson 16 and lesson 17, all of those, the reason why we do those kinds of tests is because they're really good for projecting of what the big population would be doing.
Right.
That's so if we were to do a categorical test, like anyways, like the ones we're gonna learn here, then yeah, we would have to compare with a big data. But if we did an ANOVA test, we just compare it to each other. So
Okay. That's why the ANOVA test is better. Okay.
well, that's that's my idea. We can.
Mm-hmm.
Yeah, no, I think that sounds good, but what exactly are we measuring?
Okay, so in an ANOVA test, we have to make sure that the samples are normal, and that the sample standard distribution is normal too. I don't know how to explain it, but what kind of experiments could we do with that? Making sure that because I don't know about color. I don't know if that really has to do with how can we make color preference be like a normally distributed curve? Because
Well, okay, if we're doing an ANOVA test, it's going to be right-tailed. But if we have the sample size large enough, the central limit theorem will make the distribution normal.
so we could do color preference as long as we did bigger than 30 car samples.
Yeah.
Yeah.
Because the central limit theorem will make the distribution normal. So that will be fine.
Okay, so in layman's terms, we will compare the color preference between 3 locations
Mm-hmm.
using an ANOVA test. Okay, and then what population would we be studying?
You say 30 people from a neighborhood?
So the citizens of the 3 locations, is that right?
Yeah.
Yeah, I guess.
Do you want us to take the sample from different places or just from the parking lot, from the supermarket specifically?
See, I do think that we need to make that specific. I mean, if we're going to have it be general, like we're just comparing car colors, then I think the more specific we can be about the locations that we're comparing, then the better.
Yeah.
So do you guys want to, what stores do you guys have nearby? Or the reason why I picked Walmart is just because I think it's a very good place to be unbiased, because everybody of all sorts of different backgrounds go to Walmart.
And I'm fine. I could go to Walmart.
That's okay. I have a Walmart nearby.
Or Trader Joe's. I mean, all of these big chains, I think, have a very big, a broad spectrum of people that go shop there.
Okay. Well, I said in Salem, Oregon, when I used to live it, the shady people only live there with the Walmart.
We'll see what the
But
shady people are.
I don't know what it was about. Probably because I work at night, and then most of the time that I was able to go to Walmart was in a very weird time. So I don't know, but there were a lot of shady people there, and maybe it's because in Salem there are a lot of shady people, as it is. But so that was
what? I mean, if it's okay if Walmart doesn't work, though. We can.
Salem is not part of the study, so it's okay.
I don't know, but maybe
here in Utah there are normal people.
It's like a big culture shock over there. I don't know how Walmart is in California.
It's, kind of everyone shops there, but it's a little bit more. I mean, it's going to be a little bit cheaper. So, people looking for discounts. I would say Target is probably more of the average.
Okay, I can do Target. We have a Target here.
Yeah. And what about Smith? You have a Smith, but I have a Smith and Target. Either one.
We don't have Smiths.
Yeah, okay. I think it's a Utah and Idaho thing. I have Smiths too.
Okay. Yeah.
Okay, Target is fine.
So Target it is.
Target? Okay.
All right.
Christina's like, I don't want to say anything, but I don't want to go to home.
Oh no, I don't care either way.
I don't either. It's just like I don't know what was about Salem, but my husband doesn't like to go to Walmart either, but I don't know why.
We don't want any of our professional data collectors to be stabbed during the experiment. So,
okay, so it will be Target parking lots. Okay, there you go.
3 Target locations.
All right.
Okay, what is your experimental unit? In other words, what is the smallest entity from which you are collecting a single piece of data?
A car.
Is it a car or is it a color? What is the experimental unit? Yeah, so our experimental unit is white.
Is a car color, I guess.
Yeah, I'll just put car color. Okay, what is your response variable?
So it's categorical. Oh, sorry, I was looking at number 5.
So it's quantitative because it's between our sample. Well, is it quantitative? I don't even know. It is.
Well, no, you're right. You're right. It's quantitative.
Okay.
Wait, what is your response variable?
So your response variable.
That's car color as well. Well, no, it's the average or the mean car color preference. And then our response variable is quantitative.
Yeah, we have to collect the numbers. So yeah.
Okay, so then if you go down, we just highlight E.
Yeah, that's 3 or more samples. Yeah, that would be it.
Number 7, our null hypothesis is sample mean A equals sample mean B equals sample mean C.
Mm-hmm.
An alternative is at least one sample mean is different.
Yeah, that's
I can't get the geo out.
You can't get the geo out?
No.
Ugh.
It's boxed in.
You can take the CRV.
Okay.
The people that plow the snow always box in our geo. I guess it's.
Oh, yeah.
It is white too, so maybe they confuse it with a pile of snow. Does that sound about right to you guys? Like my concern is getting us, how do we get us a sample mean with colors?
well, it will. Yeah, that's the thing.
Right. See, I mean, with colors, you could have the question be something along the lines of, the null hypothesis would be, we think that the majority of cars are white, just as an example. And then we would prove or disprove that. But that's not really what we're doing, because we don't really have any baseline data to compare it to.
Okay.
So I'm almost thinking, I'm trying to picture how our data is going to look at the end of this. Basically, I'm going to have a list of 10 different car colors, and I'll tell you how many of each were in the parking lot, and we'll each have the same.
What about if instead of colors, we'll see how well they do the parking job. If they do it good, do it very
Well, that one is like,
and that will be how well do they do it, and then we can just have 3 categories: good, average, bad, and then we'll say how bad the people do the parking job, and that will prove the theory of my husband say that most of the millennials don't know how to park. Just kidding. I don't know. I was just saying like maybe.
See, I'm thinking with, I
Instead-
think we need to have not multiple categories of our data. I think because we already have 3 locations.
Okay, so.
But I'm just trying to picture how it's going to look, how we're going to put the data in. What are we finding? We're finding the mean of what?
Yeah, that's exactly what I was saying. But if we do like not a category, it's like a qualification. For example, you just pick a number from 1 to 10. From 1 to 10, how well these people did the parking job.
yeah, but that one can be biased because what might be a 5 to me is not the same as you guys.
We have different ways of judging that.
Okay.
Well, how about what if, because I have the data, what if we did car size preference and we compare it to the national car size preference?
All right.
But that wouldn't be an ANOVA test anymore.
Well, if you have the national car size preference.
Yeah, I got it off of the what was it? And I have it on my Google Doc still. But that one would qualify as like a chi-squares test, which is next week's lesson.
Yeah, that sounds awful.
It sounds awful.
I mean, it's like I would rather just do something that's straightforward. I mean, I like the idea of an ANOVA test. I'm trying to figure out.
For an ANOVA test, we just have to make sure that it's a large enough sample and it has an even spread, or it has same spread on all of ours.
Yeah. The other thing that I can think of, the numbers that they have for the license. I mean the license plate. That will be the other thing. I don't know.
Since we're in different states, I think California has more digits than Utah.
Well, will be like the preference numbers. There will be like from 1 to 10. What will be the but that will make any difference? So I don't know. But I don't know. I just tried to think something that will be very specific and.
Okay, I got an idea. What if we did people who have regular plates and people who have like what do you call them? They're like
vanity plates.
Yeah.
Vanity plates. I'm sure we could get some sort of, well, if we wanted to get a baseline data. I mean, DMV knows how many have what.
Man, I kind of like the car color thing. What can we do with that? Nothing, huh?
No, I just, I mean, I think I think it depends on the question. What if our question was, and it can be any car color, I'm just pulling this out. White is the most common car color. And then we go and we get data from 3 different locations. And then from that, we can tell, at least from our 3 locations, if white was the most common car color in those 3 parking lots.
Oh, there you go. And then, for example, if it's white, how far away from the white the white number will be away? I mean, let's say, for example, the 30 people have only 28 cards, and these other ones have 29. These other ones have, well, you can see how far away from white or how less amount of white. So,
Okay.
which
Well,
I am guessing that white is the most, because in that case you can see is white or not white, and that's it.
okay, we're using an ANOVA test to see if white is the most common card color preference.
Yes, there you go. And I will say yes. Even my husband have a white car.
Yeah, I have a white one too. And then the population we're studying citizens of the 3 target locations.
Hmm.
The experimental unit would be card colors,
Yeah.
because we still have to know if it's white or not, right?
Hmm. And then that case is just one on the other. Won't have like many subcategories. It was just one on the other. If it's close or not close.
Okay, so then would our response variable be quantitative or categorical?
I think it'd be quantitative because we're going to be adding up how many there are.
Yeah, that will be like the amount of cards that
Okay,
are white.
so null hypothesis is so null hypothesis stays the same. Sample mean A equals sample mean B equals sample mean C.
Mhm.
And then alternative hypothesis is at least one is different. And then step 8, we will do a systematic random sample. We will go to a target. I have to change that. Parking lot, then draw from a hat, or you guys can do whatever you want to do a random start.
Well, let's all decide. Let's say we do every third, like you said.
Well, yeah, but systematic random sample has to start at random.
Oh, for the starting point. I'm sorry. I thought you meant for the determining which ones to go to.
Okay.
Yeah, so it says we will go to target parking lot, then draw from a hat the parking row to begin in, and then
Mhm.
we'll record every third car color. The types are black, red, orange, white, silver, brown, gold, green, yellow, and purple. And then the specific details of how to do it, we're all just gonna upload to a Google Doc or a Google Sheet that I'll make.
So we are going to do these different category for colors. So we're just gonna put that if it's white or not.
Yeah, what should we do?
I guess I'm looking at the ANOVA test. So if we go to the ANOVA test, we need to have lots of lines of data. So,
So we'd have to do more than one parking lot.
well, that, or we could do multiple. Well, yeah, because if we do all the different colors, then it's going to compare our means.
Yeah, let's just do multiple rows. Like each parking lot has different parking rows. And
Okay, so just list the number of cars per row in the parking lot.
yeah, but we have to do every third until we hit 50 on each row, or is that too many?
I don't know.
How big?
If I think about the parking lot that there is in Target, they only have 5 roads, and then just spots will be like 15, and so it will be every, like, I will get only 5 per road. So
I'm thinking this is more of a
5
proportion,
total.
proportion test, because I think we're going to be comparing the number of white cars to the total number of cars in the parking lot.
Yeah, that's
Opposed to an ANOVA, I think this is going to end up being a proportion test, and that the 3 areas are just part of our systematic sampling, as opposed to being 3 different variables.
Well, if we were to stick to the ANOVA, I agree with the the proportions, but if we were to stick to the ANOVA, we can record the 3 locations, and then each row would be a row parking lot. I don't know.
But would we be recording the number of white cars, or would we be recording the percentage of white cars in that row?
Yeah, you're right.
Well, but even the percentage could still be a variable. It could be 60%, could be 0.6, and that could be our data for that row, 0.6. So we could still make it quantitative in that way. But that way, if we have a short row, we don't have to have a certain number. We're just doing a percentage.
Right.
It
Okay.
makes all the rows equal.
Okay, I need to type that. So that is for number 8. Okay, we will record a percentage.
if we are doing every 3 card, it's already there a percentage. Every 3 card is already the percentage. Even if it's a big number or a small number, it's every 3 ones. It will always be like all the same percentage. That's what.
Well, but we're looking at, well, maybe.
So we will record the percentage of white over the total in one single row.
That will be easier. That will be easier because you can just multiply by the other ones, and then you will like just estimate the percentage, because it's not much. It shouldn't be a difference between the total on the each row and the total of the cards. But yeah.
Yeah, I think the percentage works good. Then in that case, we can't do the systematic percentage, but we could randomly choose the rows that we are taking the proportion from, going back to how we, randomly sample.
So we still draw from a hat which row we start in, but now we count all cars and count how many are white, and then we just count the total over that whole row.
Yeah.
No longer, we're not doing third car, we're just doing the entire row.
Right.
Okay.
Okay, but how many cars do we need to do? Like we were already say that number, right?
So how many rows should we do? Should we each do 4 rows?
Yeah, I think we're going to make sure to get enough data. 4 would work.
Yeah.
Okay, so we each do 4 rows where we count all the cars and we count all the whites in each row.
At least in Target, that will be almost the whole parking lot, because I think they have 5 roads or maybe 6, and they divide it by 2 sometimes. But each road have like a 20 or 15 card. So 15 spots. Sometimes some of them will be empty. That's the thing. But
So we will then record every car in a row and also record how many white cars in that row. We will repeat 3 more times.
the only thing is what I was going to say. We'll have to try to go when the parking lot is full. If we go do it when parking lot is half full, it won't work because we'll have a lot of empty spots.
Right.
So that has to be. That's why I was saying maybe every 20 cards we'll see how many of the white cards, just without independently about what row are they. So I can't. But that will be a little more complicated. So it will be easier if we just go to a very full parking lot, which is usually around noon or around 10. That's when the most people are in the supermarket.
Or
All weekends. But
you have a holiday coming up?
we already are over the weekend. We should have just done it like last week. But
Okay, so question 9 says, describe in specific detail how your group will collect the data.
there you go. That's the one.
You kind of already did. What sample size are you planning to obtain per population?
All right. So
Of white over total cars in row. Okay, that's it. Question 10. I just said the experiment has a large enough sample size to have a normal distribution. 11, I said no. 12, I said no. And then it says if you said no to the last two, to skip to number 19, which means to just have the professor check this.
all right.
So I will have.
So we need to approve that first, right?
Yeah. So I'll send it to him and see what he says.
And then if you complete that, can you just make sure I'll can you send me a copy of your Word document just to make sure that I didn't just miss one of them because I need to do the PowerPoint and
Yes,
some
yeah, I'll send it
the
to
ones
both.
that you are gonna send to the teacher. So in that case, will be easier for me to make sure because I might miss some of the stuff probably. Just to make sure that we are on the same page and
Yeah.
okay. All right.
Well, thanks, Juan. That's a great idea.
Yeah, thank you so much. That will save us a lot of things. And then the final project is the same one, right? But just finalized. Is that what it is?
Yeah. Yeah. This week we just get the design approved, and then we'll do the next step next.
All right. Do you want to start recording another recorder for that, or should we continue with this exam?
I don't think we have to submit a recording for the design the study. This is included in the lesson 16 recording.
Okay, so that we can just continue with the exam then. Okay, let me go back there. Just one moment. Why do I have so many windows open? Sorry. There you go. I have like 5 windows open. I will close some of them. Okay.
Okay. Are you guys sure you're fine with this for this design and everything?
Yeah.
I hate it, Juan. I totally hate it.
We could do Nord stuff.
I love having a design where we don't have to talk to people or anything.
Yeah, me too. Okay, I was just kidding. Yeah, this is perfect. Thank you. Thank you for helping that. That's a lot of help.
Yeah, so I will create a Google Doc where we can input the data we find. And anyways, yeah, we'll move on from there. So I'm on question 3.
In a pie chart, why are the slices sector different sizes? Well, the first option is the size of each slice is random. The second one is the size of each slide is determined by the numbers of category. Each slide represents a category, and the area of each slide represents a proportion of the total occupied by the category. I think that's the one.
Yeah.
And the pies are more visually appealing when the slices. That's ridiculous. Okay. Sorry, that's funny. Uh, okay.
So the next one is about bar charts and Pareto charts. The third one.
Yeah, the only difference between bars charts and Pareto are that the bars Pareto charts are ordering largest to smallest, going from the left to right. All right.
Okay, it says we conclude that p hat is normally distributed if the sample size times p is larger or equal to 10, or the sample size times the quantity 1 minus p is larger or equal to 10. If p is true proportion or the sample is p the true proportion or the sample proportion?
It's true proportion.
True.
N is the sample size.
Mm-hmm.
If p is 1/4, what is the smallest n that satisfies that requirement?
Uh,
Set it equal to 10 and solve for.
Well,
that would be 40.
no, P, because P equals X over N.
Yeah.
Oh, wait, that's P hat. Hold on. Oh, wait, wrong chapter. Just a sec. Oh, P hat equals S over N. Oh,
Yeah.
7.
It would be 40.
Yeah, me too.
Larger than 40, so 41.
Well, it says greater than or equal to.
Oh, okay. So 40.
Mhm.
40.
Okay, so suppose n is 24 and p is 0.4. What is the mean of p hat? So this is where we can do that equation. I forgot where it was.
The so is a square root of p1 minus p over n.
Yeah.
So yeah, that would be.
Wait, that's the standard deviation.
Oh, that's the standard deviation of p. Yeah, you're right. Sorry.
I think P hat is the same as P, isn't it? It was just like,
Okay, so on the textbook in section 3.2.2, it says that the sample proportion p hat is normally distributed if n is large. The true population mean of the random variable p hat is the mean of p hat equals p.
okay, that's what I thought. So I think it's just 0.4.
I thought we have to add it to each other.
Is it large enough?
Oh, it's okay. Oh, okay. Yeah. I just got confused because at the beginning they added. All right.
Then we do.
And now the standard deviation, the equation that I was just talking about. All right. Okay. So the standard deviation, the
0.01.
zero 4 0 4 0 4.
Christina,
6.
when do you?
That would be 1 over 40.
Well, I haven't been able to sleep very much.
1 over 40.
So, like, when do they start to sleep?
How old is he?
He's 3 months today.
You're getting into the zone. You're moving into it. I still remember the first time my oldest slept through the night. It was 9 hours. And I woke up terrified. Like, what happened? Oh no, something went wrong. And he slept through the night. So that's not to say he continued to sleep through the night, but that was the first time. You're getting there. You're getting there.
Yeah, depends of the kid, but I'll say that I don't know, how is the mom? Does she sleep sometime?
No. Takes it out on me. Look at me, guys. I'm miserable.
No, I was just saying that if she is the one that is lightly asleep, probably he will be most likely lightly asleep. That's what I was saying. I wasn't saying that she should be sleeping. I wasn't talking about that.
Okay. So yeah, if I sound abrupt or kind of weird, it's because like I don't even know what I'm saying. So
Okay, so number 9 was 0.1, right?
Yeah.
So we're on to 10.
All right.
what is batting average is 0.3. We want to determine the probability she will get more than 35 hits in her next 100.
At bat.
So we do the same thing, right? That we just did.
I want to do that, but I think here we have to do x over n.
X over n for the first one. Oh, yeah. That's
wait, the p hat is 0.3. Wait, I don't know.
Well, the population, yeah, p is 0.3. See, that's where this
X over is 2 decimal 0.3 30.
Because I'm thinking it's supposed to be x over n, which would be 0.35.
The p.
P hat.
Oh, p hat.
Okay.
35.
I don't know why they.
So then the standard.
But if we're going to find a z-score, then we're going to do that.
100 over. Yeah.
So then we just take the square root of that p minus, or p times the quantity 1 minus p over n, all square root, to get the standard deviation.
It will be
yeah, so 0.3 times quantity 1 minus 0.3, all divided by 35. The square root of that. I get 0.07.
35? You mean 100, right?
Dang it!
It's okay. No. 0.0458.
Yeah.
I got 0.0458.
Yeah. So it's 0.046.
Oh yeah, 3. Okay, z-score.
Well, at least something that we're familiar with.
I know. 0.35 minus 0.3 over the standard deviation, which I'm going to just save this one. Hold on.
1.087. 3 decimals. 1.087.
1.087.
I've got 1.09.
1.09.
I didn't use the standard deviation from question 11. I used the full thing without rounding, because that's what they were doing in the classwork.
Oh, okay.
Okay.
So we don't need to have 3 decimals then?
Yeah, we do, but I have 1.091. That's what I have as the answer for question 12.
Mm.
What kind of calculator do you have, Lucia?
Well, it's on my phone.
What?
So I because of this, I learned how to use the memory yesterday. So when
Oh,
I calculate the standard deviation, I just put that into the memory and then divide by it. That was the only way I could get the answers that they were coming up with in the book and in the assignments. Because they would use the full thing. They wouldn't round the standard deviation.
Okay. What is the probability that Brittany gets at least 30? Wait, did we already talk about this?
No, we've got the z-score, so now we have to put it into the applet to get the probability.
is that what? 136? I'll say.
Wait, does it say greater than
That's what I was just looking at.
at
At
least? What does that
least.
even mean? Less
That,
than or
I don't know.
no, it's greater than, right? It's
Yeah, she will get more than 35 hits in her next 100 at bat. So I would say it's greater than. So I've got 0.138.
0.09.
I have to start doing what you're doing. I just, yeah, don't, no more rounding.
I know that's, I mean, the answers are very different. 'Cause the answers I was getting on the assignments were like totally different than their answers. And so I had to figure that out.
In the prep assignment?
Yeah.
Yeah, there
On
was
the
like so many
video
typos.
and on the video too, which he was just doing the problems from the book. But yeah.
Okay, so to get standard deviation, we do 0.52 times 1 minus 0.52 divided by 2000.
Probability
Divided by 2000. The 0.11. 0.011.
Oh wait, I have to square root it. I got the same thing you did, Evelyn.
Okay. And we have two more.
Hey, how come there's no intervals?
That's in the next one, isn't it?
Oh yeah, duh.
So for 14, you got 0.011, right?
Yes.
Okay. Sorry, I'm behind.
No, you're fine. 1.79.
So z-score.
3 decimals.
Question is that?
See, so it's, since the election is getting less than 50% of the votes, would that be 49%?
What's 50.52? It's 48%, right?
Right, but we're not subtracting that from 0. We're just trying, or from 100. Because I need, to get the z-score, we have to take p hat minus p. And p is 0.52. That p hat,
It's,
It says getting less than 50% of the votes. So do we just do the 50%?
maybe. Let's try it.
0.5 minus 0.52. Get a very negative number.
yeah, minus 1.79.
Yep, that's what I've got.
So then I do the standard deviation. Did we already find it? Oh yeah.
Point.
I got minus 1.81.
I've got minus 1.79.
Dang it.
The other one is
Yeah, it's p hat, so 50.5 minus 0.52 divided by 0.011.
No, don't do 0.011. You've
Do the
got to
whole
do the full answer for the standard deviation. Don't round
thing.
it. Don't use the rounded number.
Where is that number at?
okay.
Divided by population 2000. Ah, wait.
57.
Square root of that. Okay, so I got that number. So then I go, what was it, negative 0.002?
Negative. Well, which one? The 15?
Yeah. Negative 0.02.
Negative 0.2.
Okay, I see.
P hat minus P, negative 0.02. So you've got negative 1.79?
Yeah. So then we plugged it into the normal probability applet.
Right. And since it's less than 50%, we shade the left side, right?
Yeah.
And then, yeah, the
So I've got 0.037.
yeah, me too. 0.037 for 16, right?
Mine just goes 0.0367. Oh, 416. Yes, I'm sorry. I thought you were saying numbers. Like, wow, my
So
program
we
didn't go that high.
yeah, 0.037.
Yeah, for question 16.
Okay. There you go.
Well, should give it a try.
We'll see how much it is.
Yes.
All right.
100%.
Darn it.
What happened?
Missed one.
Which one?
Which one?
Number 9.
9.
Number 9.
But what did you put?
0.01.
Oh, no, just 0.1.
Oh,
Then you have to take the square root.
darn it.
0.0. Yeah.
Hey, so back to number 14.
Mm-hmm.
How come we use 50% again? I was just saying that because that's what it said on the book. But
I know, because, well, and I guess it does make sense, because if you choose 50%, then when you shade the applet, you can just shade either the below 50% or above 50%. And that's where we decide. So I think 50% was good, because it could be 49.999%, which is still less than 50% of the votes. So I think we just always use 50% in those situations. And then when we shade the applet for the probability, we'll do the right or the left, depending on if we're getting above or below 50% of the vote.
Sorry, that was my computer.
That's my reasoning anyway.
okay, I'm gonna end it and then I'll start a new video.
Okay, sounds great. Thank you.
Thank you.